Yesterday, we were discussing that why we use ordinary least squares. Now, using least squares method, we will be finding out the estimates, beta 1 hat and beta 2 hat. So we have yi equals to beta 1 plus beta 2 xi plus ui. This was the population regression function. But we are not given with the population data completely. We are never given with that. So we have to rely on the sample, right? So sample is yi hat plus ui hat. What is yi hat? Beta 1 hat plus beta 2 hat xi, and ui hat is the estimate for ui, sample regression function. So if you have not seen the earlier video, please have a look at that so that you understand this better. And what is our residual? Yi minus yi hat, which is, or you can say, okay, I'll write it like this: yi minus beta 1 hat minus beta 2 hat xi, right? And if I square this, it becomes like this. And then I sum this square, right? This is not looking good. Right. I sum this square. Right, beta? And I need to minimize this. I need to minimize this residual. I need to find out such beta 1 hat and beta 2 hat, which is going to minimize the residuals. The sum of squares of residuals, I'm sorry. Right? So please write choosing beta 1 hat and beta 2 hat in such a manner for a given sample such that summation of ui hat square is as small as possible, right? Is as small as possible. So del of summation of ui hat square upon del of beta 1 hat. The way you find out first order condition. So beta 1 hat and beta 2 hat, you're going to choose them so that the summation of ui hat square is going to be minimized. So it is minus 2 summation of yi minus beta 1 hat minus beta 2 hat xi equals to 0, right? And del summation of ui hat square on del of beta 2 hat is minus 2 summation of yi minus beta 1 hat minus beta 2 hat xi into xi equals to 0. Fair enough? So how can I write this? Is minus 2. When it will go on that side, it will become 0. So you have, and I can just open this up. Summation of yi hat minus n beta 1 hat minus beta 2 hat summation xi equals to 0. I hope you know this, that when I'm going to sum over a constant, so if there are n terms, it will become 2n. And if I'm going to sum like this, 2xi ka sum, so it will be 2 summation of xi, right? So I'm sure Vidhi might have done some summation rules in her introductory statistics lectures. You might have a look at that also. So you can just write summation of yi equals to n beta 1 hat plus beta 2 hat summation xi, and we'll call this as 1, right? Here also this minus 2 will go there, and this will become summation of yi xi minus beta 1 hat being a constant will come out of the summation sign, summation xi minus beta 2 hat being constant will come out of the summation sign, summation of xi square. And once you will write this, so I can write this as summation of yi xi equals to beta 1 hat summation xi plus beta 2 hat summation xi square plus beta 2 hat summation xi square, right? So I can write these two equations in the matrix form. I can do that, right? So writing 1 and 2 in matrix form. So what you will have? You will have n summation xi summation xi summation xi square. Beta 1 hat beta 2 hat right, summation of yi summation of yi xi, right? Summation of yi xi. So I hope you know, using Kramer's rule, I can get the value for beta 1 hat, beta 2 hat. So I'll do it slowly. Please have a look at this. By Kramer's rule, so when I use Kramer's rule, so I want to find out the value for beta 1 hat first. So what I'll do is that I'll substitute this column onto this column, right? I'll substitute this column onto this column. So I've done that. And this column will remain intact. Whole upon the matrix of this coefficient matrix, right? So that is intact. So it becomes what? And summation xi summation xi summation xi square. Fair enough. So we'll just calculate this. So it becomes what? Summation yi xi minus summation xi. No, summation of yi summation of xi square. Summation of yi summation of xi square, right? Into, minus summation of yi xi into summation of xi, right? Into summation of xi whole upon n summation of xi square minus summation of xi ka whole square. Later on, I'll tell you an easy way to go about this because nobody will be remembering this. So, and then what is beta 2 hat? Again, using Kramer's rule. For beta 2 hat, what you do? You substitute this column onto the second column of the matrix. The first column remains intact. So you will be replacing this column with this column. Right? That's what you'll be doing. The first column will remain intact. So it becomes what? First column is intact. Summation of yi. Summation of yi xi. And summation of xi. Summation of xi. Summation of xi square. And it becomes what? N summation of yi xi into summation of yi summation of xi whole upon n summation of xi ka whole square minus summation of xi ka whole square minus summation of this guy xi ka whole square. That is what beta 2 hat is. That is what beta 2 hat is. But we will be opening this up. We'll be opening this up properly. So let me tell you one thing. If I want to write, just look at the denominator of beta 2 hat. So let's say I open this up. What will this be? Summation of xi square plus x bar square minus 2x bar xi. So this becomes what? Summation of xi square plus n x bar square, because x bar is a constant, minus 2x bar summation of xi. यही होगा. But x bar is what? Summation of xi upon n. So I can write this guy as what? Xi square plus n. In place of x bar, what can I write? Summation of xi upon n ka whole square minus 2 x bar. X bar ki jagah what can I write? Psi upon n summation of xi. Xi square. अब ये this one n will get cancelled with this n square. So in the denominator we'll just have n. So it is summation of xi ka whole square upon n minus 2 upon n summation of xi ka whole square. So it is summation of xi ka whole square minus, sorry, summation of xi square minus summation of xi ka whole square upon n. You with me? So this thing is what? N summation of xi square minus summation of xi ka whole square upon n. Are you with me? So your denominator is what? So if you look at the denominator, denominator is this guy. N summation of xi square minus summation of xi ka whole square is n into summation of xi minus x bar ka square. So this n will go there because ये सब चीज क्या है? This is this only. है ना? Okay. Now you look at the numerator. Now I'll write it. Just wait. So now you can can you open this up? Summation of xi yi minus summation of xi into summation of yi, right? Summation of xi into summation of yi. Okay, now can I just use this? If I open this up, then it will become what? Summation of xi yi minus y bar xi minus x bar yi plus x bar y bar, like this. So what is this going to become? Summation of xi yi minus y bar, summation of xi minus x bar, summation of yi plus n x bar y bar, like this. Okay. Summation of xi yi minus, in place of y bar, it will become what? Summation of yi upon n. Sorry. X bar की जगह minus summation of xi upon n. Right, beta? Okay. So what can I do? So you have what? Can we write it like this? एक तो ये cancelled है. So you have what? Summation of xi, summation of yi upon n. This is plus, and this is summation of xi into summation of yi upon n. This is minus. So this guy will get cancelled up. Sorry. And this thing will become what? N summation xi yi minus summation of xi n sorry, minus y bar. And you will get what? N summation of I'm sorry guys, xi minus x bar, yi minus y bar. You with me? Huh? Now can we write this? So in place of n summation xi yi minus summation of xi into summation of yi, what can you write? You can write n summation of xi minus x bar into yi minus y bar. And in place of this guy, you can write this guy, xi minus x bar ka square. This n will get cancelled out. And what are these? These are deviations from mean. Xi minus x bar is what? Deviation of x from mean of x. Yi minus y bar is what? Deviation of y from mean of y, like that. So I will write this that as the lowercase letter. So make this thing clear. Xi minus x bar is small xi. Deviation from mean. Yi minus y bar is small yi. Deviation from mean. So the idea is that you can write beta 2 hat as simply summation of small xi small yi upon summation of small xi square. Right? Now about beta 1 hat. If you remember, you have written this expression. No? You've written like this. Can I just divide both the sides of this by n? So what will I get? Summation of yi upon n equals to beta 1 hat plus beta 2 hat to summation of xi upon n. Beta, what is summation of yi upon n? Y bar equals to beta 1 hat plus beta 2 hat x bar. So how can I write beta 1 hat? Beta 1 hat is then y bar minus beta 2 hat x bar. And you know the value for the sample mean of y and sample mean of x. You have the value of x and y, na? So you know the values of x and y, sample mean of x and sample mean of y, and you know beta 2 hat. What is beta 2 hat? Beta 2 hat is what? You've just calculated summation of small xi yi upon summation of small xi square. So this is easier for beta 1 hat. But for beta 1 hat, you need to calculate beta 2 hat then. Otherwise, you have to learn this formula, right? So I think I've given you the complete derivation. I hope it was useful to you. Thank you, beta.